So let's go and start with something. We have a scene that we use for pretty much every demo that we do with Krakatoa, and it has become more or less the major showcase explaining what Krakatoa does or what it could do and so on. This was created back in 2006 based on a model of the Mini from the Italian job. Frantic Films did previews on that movie and used those minis for the chase sequence. And at some point, one of our artists took it and said, "Okay, I'm going to distribute particles on this model that I had, and I'm going to do a camera projection of a different renderer that was rendered with a ray tracer called Brazil, and the result was projected on the particles, and the color was locked on them. And then what you see currently in the viewport is exactly 2 million particles. So this is a very low resolution. You'll hear me talking about numbers a lot today. And 1 million is considered kind of the low end of where you start working with Krakatoa, and 2 million is almost a preview quality data. The actual car, the real sequence will actually be saved as 40 different variations, 40 different wedges, different distributions. That means we had up to 80 million particles to render at a high resolution. But right now, I'm using only 2 million, and I'm actually loading them all. If I start moving the time slider, obviously it won't be very fast, and because Maya doesn't really see sort when an object is selected, I'm going to deselect it and just go to different frames and show what is happening with this kite. Actually, we are blowing the particles away, but they're keeping the color locked on each particle. And this is one of the effects that people like to use Krakatoa for. Take a solid-looking object and then blow it into dust in the wind. I'm going to switch to a couple of different display modes. We have obviously large dots, which is much uglier, but sometimes you might want more visible particles. So instead of drawing with the small dots, I can use the large ones. If I display the velocities, portions that really have zero velocity don't really draw anything right now. So I'll be actually switching to the small dots most of the time. And of course, I can control the percentage of particles being loaded. And currently, we're loading every end particle, which means that if I have a very long sequence with 2 million particles, 200,000 particles are being loaded. But we are skipping over every 10. And this is relatively slow to load. As you see, it's actually not much faster to scrub the timeline than it was before, because our files, the particle files that we are reading, are zipped, and the whole stream has to be uncompressed in order to get every 10 particle. For these cases, we actually have a mode which is called the first n particles. And in that case, you'll see that if I start moving with only 200,000 particles, it's obviously much faster to move. The trouble with the first 10 is if I come to a frame where the order matters, in this case, the diffusion of the car was actually stored in the beginning of the file, and the rest of the car was later. Obviously, I'm seeing only the diffusion part, and if I start moving the percentage slider, we're going to review more and more until we reach the 100%. But in many cases, just showing a fraction, like the first 20 or first 10% of some cloud, is good enough to get an idea of the what is going on in the file. I'm currently using an object that ships with Krakatoa for Maya, which is called the PRT loader. It's not really a Maya particle system. It's our own implementation that allows you to do things like 20 million or 100 million points without actually waiting for an hour. And it's basically just a object that loads files from disk. We support our own PRT format. We support natively the RealFlow bin format. We also support comma-separated value text files, so you can load pretty much any data from any source. And this object allows you to retime, create custom timing, ping pong back and forth, or slow down, speed up, and so on. The animation, it interpolates correctly the new positions from the velocities and the timing settings. You can limit it to a certain range, so it stops at some frame and doesn't continue, and so on. And it has the loading options, and it allows you to pick any number of files, not only just one. You can mix multiple files in a single loader. they get accumulated together. We'll be talking about this a little bit later, because that's one of the ways you actually work with Maya, producing multiple particle variations, multiple wedges. We call them partitions, in order to increase the density. Let's actually go and render frame. I'm going to open the renderer settings. You see that Krakatoa is already assigned as the renderer. It appears just like another renderer inside the Maya render settings dialog. And of course, we can switch to the Krakatoa settings tab, and we'll see that there are lots of panels here, but the major panels are actually expanded, which control the appearance of the actual rendering. We'll be visiting all these panels in the next half an hour and looking at what is going on there. But one thing I want to tell you, since we are doing a broadcast and we are recording the whole session, I actually went into the affinity of Maya and to check the first CPU. So right now I'm rendering on 7 CPUs, not on 08. It shouldn't really matter much time-wise, but Krakatoa is highly multi-threaded, and if I would hit render, potentially would lose the audio connection with me because the computer would be too busy calculating particles. So hit the render button, and it will load the particles and draw the particles. And it took, if we take a look at, oops, I clicked the wrong button, so another Maya is opening in the background. But this is the output window of Maya, and you can see that we loaded 2 million particles. It took 61 megs to store that data, and it took 1 second to load that. I'm going to close this other Maya when it finishes loading, because I just clicked the wrong icon. And the actual drawing took 0.2 seconds to sort the particles, 0.4 seconds, 0.4 to actually draw them. So 2.8 was the total time. It's approximately 2.5 with all 8 CPUs, I would say. Okay, let me close this. And we're back to normal. I'm going to move to another frame where the car is actually dissipating, probably around frame 100. And I'll hit the render button again. We should get very similar render time. It will hopefully load the particles and render, unless the loading of the other Maya caused some surprises. Yeah, that took pretty long. So let's take a look. It shouldn't be taking that long because we're loading the same amount of particles. Yeah, this is the correct time. So it's, again, about 1 second to load 2 million particles, and total time of about 2 seconds. Now, since we have velocities stored, we could enable the motion blur. Krakatoa is using multipass motion blur. But there are a few things that I want to show you here. The first thing is I'll render 4 passes with 180 degrees shutter angle. I'll hit the render button. That means it will load the particles once, and then it will draw them multiple times, and the whole thing will take about 7 seconds, 6 point something. Take a look, 6, actually 6. And multiple passes were rendered. I mean, multiple samples were drawn for each particle moving. If I open the shutter too much, we might start seeing stepping. So we have an option to render with jittered motion blur. Jittered motion blur randomizes the position of the particle along the velocity vector, and it's slightly slower because of the way the sorting works when we are jittering them randomly. So the time will be slightly longer than the 6 seconds that we had before, but the results will be generally more diffuse. It took 10 seconds and a little bit, probably. One thing that's interesting is you'll notice that the particle segments slider actually allows you to go down to 1. And when jittered motion blur is on and you have only 1 segment, that means that only a single pass will be drawn, but it will still jitter the particles along the normal, I mean the velocity. That means that if I render now, only 1 drawing will be performed, but those particles will be drawn actually more diffuse than they were before. I'm going to store this one, and I'll disable the motion blur and render another one that is without motion blur. And let's see if we see a difference. Actually, not very obvious, but the particles, I don't know if it will be visible really on the broadcast, but it actually jitters the particles without doing multiple passes, and it might be good for a quick preview to get an idea. With a lot of particles, it's sometimes enough to just randomize them along the velocities to create the appearance of motion blur.